In front of us we have a 1070 Ti by EVGA. It is the super clocked with the ACX 3.0 cooler. It looks like this if you've never seen it. So anyways, as you can imagine, the thing is dead, but it's not dead in the usual way. So normally we expect some, dead, electrical component that has died naturally over time. In this case, however, the only real problem is that it was sold to this card was bought at some point by a very neglectful owner who has basically ruined the PCB in several places and caused the card to break. So this card that you're looking at right now, it's actually in warranty. I checked the serial number. It has 4 months of warranty, but nobody will ever get to use it because, as you can kind of, I'll zoom in, but just as an example of what kind of owner this card used to have, if we zoom in on this transistor in the top left, you can see that it's not really attached to its solder pads. In fact, the solder pads have kind of been ripped off. So somebody has opened this card up, screwed around, broken a lot of things, and now it's over here. So okay, so of course before we work on this card, we want to make a confirmation that the card itself is worth fixing. We want to see that, for example, that there's no cracks on the GPU die, given the kind of owner that this card used to have, and that it is otherwise, in good health. So we're gonna check all the base rails, the voltage rails, I should say, as well as just all the rails, period. So first, we're gonna check 12 volts and 3.3 volts at the PCI Express slot. So I have my multimeter in beep mode. Now, if we so the first 3 pins, the first 3 pins are 12 volts. As we can see, we don't get a beep, but ground does, so we know that 12 volts is not connected to ground. Then 3.3 volts is the 4th pin going left from the notch. So the 5th pin is ground, so if we find the 5th pin, and we go 1 to the right, it all looks good. So that's good so far. Now let's check 12 volts from the 8-pin connector. So checking this inductor, we don't have a short, as you can see. Yep, it's good. So it's high enough. Now let's go to resistance mode and check the actual voltage rails that are required to run the card, not just the base voltage rails. So first we want to check 5 volts. So just keep cycling, that's good, that's a good sign. Now we want to check 1.8 volts. So for this you expect to see about 900 ohms. 897, high enough. So now for the PEX rail, I generally expect to see 40 to 100. And we get 112, that's actually very good. It's generally a good thing to see it much higher. You generally want to see a high resistance and not a low one. So now let's check the memory controller. And it seems like we have a short. So usually on these Pascal cards, GTX 1070s, 1080s, 1070 Ti's, especially with this PCB. This PCB is very, very similar to the reference PCB on both the 1070, the 1070 Ti, and the 1080. Even a lot of the custom cards use this PCB. So what happens is, usually what you see is that when you have a short on the memory phase, right, it's often accompanied by a dead GPU and by burned inductors in the bottom right corner. Now, in this case, I don't think that's why we have a short. I think more likely than not, our previous owner has knocked over a few capacitors or whatever and caused a short. So let's just check the actual, the resistance here basically, at the pad itself. So it seems like we have 570 plus ohms. That's good. That's high enough, I think. We'll get back to it later if we think there's a problem. But it seems like the short. So it seems like the MOSFET itself is okay, which is usually what kills both the GPU, the memory, and then burns these inductors here. So we're going to switch over to a magnifying glass, and we're going to take a look at what this previous owner has done to the card. Okay, so as you can see, we're zooming in on the GPU die with a magnifying glass. The first thing we want to check if there are any cracks in the GPU, on the die itself. From just looking at it, it seems like it's perfectly good. Thankfully, it seems like our previous owner hasn't actually managed to destroy it. So even if I can't get the PCB working again, I could probably at least salvage the GPU. So that's good. Now let's move over to some of the memory damage that, at least what I can see, just by looking at it. So remember that we had a short on the memory controller. So you can see these. Let me just zoom in a little. you can see these inductors here, sorry, not inductors, these capacitors here. This is obviously not a good sign. These capacitors are essential to the stability of the, of the memory. We can take a guess that maybe it's one of these capacitors that's causing our shorts. Well, I'm not going to get to it right away. So that's okay, that one's missing. So the pads, at least, it seems like the pads are at least partially attached. This is a good sign. This tells us that maybe this thing is salvageable and we can get it to run again. So now moving over to the area of our 5-volt buck converter, we again see that we have this transistor that's been knocked off. So the pad is still there, thankfully. There's also a resistor knocked off, as well as, I guess, another resistor. This is, again, a little bit worrying because of its location to the 5-volt buck converter, which, by the way, is an MP1475, is labeled ADPJ. ADP is the actual marking, while J is the year code or batch code or whatever. So yeah, because of its location to the 5-volt buck converter, I'm a little concerned. The feedback circuit, for example, is probably in this area, and I would hate for it to get damaged. Moving over to the rest of the card, it seems like everything else looks good. Thankfully, thankfully there's no other serious damage, at least on this side of the board. But that brings us to, of course, the next side of the board. So, if you don't know, this card does not have a back plate. This is kind of unfortunate, because what you see is that a lot of these cards that have no back plates, they tend to have components knocked off on the back. So if we just go over to, first let's go to the GPU, the back of the GPU. So we can see a scratch there. That's not a good sign, but that's probably not too bad. But if we go to this corner, we see we have a missing capacitor. This could, of course, affect the stability of our GPU. These capacitors are, without a doubt, essential. Then we have another missing capacitor, and actually, no, four missing capacitors. Again, it could affect the stability of our GPU. This is, I always hate seeing stuff like this. This is probably not too much a problem, but the other problem is if we go up, you see these capacitors and, knocked off. So these are actually connected to the PCI Express slot itself for the second last, and third last lane. So we have a suspicion that if we fix everything else but this, the card may not actually work in x16 mode. So, we have to replace that too. Moving over to our memory. So we see that gash as well as the missing capacitors. Again, same story. This actually might be the source of our short over here. I'll have to see in a moment. So everything else thankfully looks good over here. Oh, nope, there we go. There's another. So this is the wiring for, I think, our HDMI port. So seems like we're not going to have working HDMI either. What a shame. And that's like I said, I'm hoping that a ripped off transistor is not essential, but we'll see. We'll see. What a shame. Ugh. As you can see, I have my work cut out for me. Okay, moving over to this side of the board. Hold on, let me just look at it off camera first. Okay, so a couple of things I want to point out. Firstly, if we go over to here, now you may notice that, okay, if I zoom in, like, okay, in the middle, right? Okay, you see the Q519? This transistor is responsible for setting the enable signal to our UP9511P. So we can guess that even if we fixed everything else, we wouldn't have, the GPU VRM would not turn on, and neither would the PEX rail. So we have to put that in. You can still kind of see the transistor's legs over here. They're still sticking out. Thankfully, the pads are not ripped off, so that's a good sign. There's also that gash over here. I'm not too sure what to think of this. I'd have to look at another PCB to see what its relevant is. Looking over at the actual chip, the first thing I notice is, okay, first we're missing we're actually missing the voltage in. So there's a capacitor and there's a small resistor. The capacitor is, I'm trying to zoom in, put it in the middle. So it would be normally there. It's a 5-volt capacitor. It's a capacitor for 5 volts. This is the voltage in for our UP9511P phase controller for the GPU VRM. It's also missing a resistor, which I believe is 2.2 ohms. I'll have to double check this. So that wouldn't turn on either, even if it had everything else. Now going over to our 1.8 volts buck converter, we can see that gash, and it's missing both a resistor and a capacitor. I'm not sure its values, but this is not looking, at least the pads are still there. Oh, I always hate seeing stuff like this. You know, this card could have been our made, and somebody would have, and EVGA would have fixed it themselves out of pocket. But instead, you know, it's over here, and it's, well, PCB repair is a little out of my comfort zone. Personally, I prefer to stick to just changing bad components. But like I said, so we'll get, okay, the first thing I'm going to do is I'm going to try to deal with the memory control, the short memory phase. You know, if it turns out it's a GPU that's actually dead and it's missing the memory, so I'm sorry, if it has a dead memory controller, then I can stop there and I can not even work on the card. But yeah, let me just get onto that, and I'll come back with what I find. Okay, so as you can see, I've taken off a memory module and two capacitors up top. I used a power supply on the memory face, and I found that the GPU heat up, the memory module heat up, two capacitors heat up, as well as one on the back. Actually, I think I can quickly show you. So the capacitor I'm talking about, it was visually bad. I showed it previously. Oh jeez, oh Jesus Christ. So the capacitor in question was, let me see, this one here. It looked bad, so I just went ahead and took it off. Okay, now when we check the resistance of our memory phase, power phase, you'll find that it's about, let's see, 93, 94 ohms. That's a pretty good sign. I'm gonna go ahead and say that the chip, the GPU itself, is perfectly good. So, you know, obviously I'm gonna go ahead with the repair. So, as you may know from watching my videos, assuming we have the base voltages 12 volts and 3.3 volts, which we're going to assume we have, the order in which the voltage rails turn on is 5 volts, 1.8 volts, the PEX rail 1.02 volts, or just 1 volt, as I sometimes say, 1.5 volts for the memory phase, and then about 0.8 volts for the GPU on standby. So let's go ahead and turn the card on, and let's see what we get. So the card is on. We have 5 volts. Do we have 1.8 volts? We do not. So because we don't have 1.8 volts, we won't have the PEX rail, 1 volt, and we won't have the memory either. And by extension, we also won't have the GPU. Okay, so despite the fact that 5 volts seems perfectly good, we want to restore the circuits over. Actually, let me just zoom in. This might be better. Okay, so as you can see, there's a damaged transistor from the previous clip. We're going to restore this, and we're going to restore, we want to just put it back in place. I don't actually know what it does. I'm guessing it's not too essential, but I'm going to put it back anyways. So, and then we're going to focus on why we don't have 1.8 volts. So let me just go ahead and do that, and I'll be back in a moment. Okay, so I've replaced that one transistor we talked about earlier near the 5 volt rail. I believe it's this one over here. The marking is M2A. I'm not very confident on what the transistor is. I think it's a MMBT2222AW by Panjit Technology, I think they're called. There's another, like I said, I'm not that sure what it is. I can't get any reliable information on it. I've also made another change, and that's the change. Okay, you may remember that near our near our 1.8 volt buck converter, we had that gash, and we had a missing capacitor and a missing 0 ohm resistor. I've gone ahead and just installed some random 0 ohm resistor and a capacitor from a dead card. Let's boot the card up, and let's see if we at least have 1.8 volts. Okay. Starting the card. Okay, so remember we had 5 volts before. Let's just check it anyways. 5 volts is expected, and 1.8 volts. Yes, we have. Oh, actually no, you can't see it very well, but we do have 1.8 volts. So yes, we've managed to get at least one more voltage rail working. The next thing to focus on is the 1 volt PEX rail. Now, in this case, actually, I didn't check. Let's maybe it's on. Actually, no, it's not on. I know it's not going to turn on because we're missing enable. Okay, I know because of the damage on the back of the board, but just checking it anyways. like I said, okay, 0. So if you don't know, the way the PEX rail works on, 1 volt voltage rail works on GTX 10 series, I think most of them, if not all of them, actually, well, more or less a lot of them. So the buck converter, it's a UP1728Q, right? So the enable signal for our UP1728Q, it is actually also the P good signal for our, if I can get a UP9511P, our phase controller for the GPU VRM. I can't get a very good image. Now, the reason why this is relevant is because this, there's a few things missing. Firstly, we're going to be missing voltage in on this chip, and the reason why is because we don't have our resistor. There's a resistor here that supplies voltage in. It connects to 5 volts. It's missing currently. I think this is about 2.2 ohms. I'll confirm it. And then we're also missing a transistor here. This transistor is responsible for sending the enable signal to our UP9511P. So without either of them, this thing will not turn on, and by extension, it will short the 1.8 volt enable signal for our 1 volt PEX rail. So that's why our PEX rail isn't turning on, or at least I think that's all that's wrong. But I'm going to check what the transistor is and install it, and I'm going to install both this missing capacitor here and the missing resistor. Okay, so let me see if I can get a good picture. Okay, so I'm not sure how visible it is, but I've reinstalled. Give me a second. Okay, so I've reinstalled the resistor that carries the voltage in to our UP9511P. As it turns out, this is a 1 kilo ohm resistor. At least on the 2 cards I checked, they were both 1 kilo ohms, 1000 ohms. As for this capacitor here, according to my multimeter, it's 380 microfarads. I'm not that certain. I don't really trust my multimeter. And finally, this transistor, the one responsible for sending the enable signal to our UP9511P, the marking is K72, and the model is, according to a basic Google search, it is a 2N7002DW. I'm not that sure on it, but when I am, I will absolutely link this datasheet in the description. If you want to fix graphics cards, especially GTX 1070s, 1080s, 1070 Ti's, and even RTX cards, you need to know what transistor this is. It's essential on a lot of cards. So in either case, let's plug the card in and let's see what we get. Hopefully, we'll have all our voltage rails, but of course, if we do, the card's not yet finished. So hold on, let me just plug everything in. Okay, turning everything on. So as you may remember, we took off the memory module here. Because we're missing a memory module, we expect the card to boot with, some symptom indicating memory corruption. In particular, we expect a backlit monitor, but we expect the monitor backlight to turn on, but we expect to have a blank screen. So, without further ado, let's start the card. Okay. Hopefully you can see pretty well. Okay, so let's just check voltage rails in order. So first we have 5 volts like expected. Now we also have 1.8 as we want. And 1 volt as we expect. 1.35 for memory, that's good. 730 millivolts for GPU VRM, that's good. So at the moment, it's about to start a memory test, I'm guessing. I'm gonna very quickly plug this in so it doesn't overheat. And we'll let the computer do its thing. It should shut off by itself when the memory test finishes, and when it finishes, I'll let you know what I find. Okay, so I've run Matt's mods on my on the 1070 Ti. If you're wondering, I will eventually have a guide on using Masson mods and how to install it and how to use it and how to, just run it in general to diagnose memory corruption on an NVIDIA card. I'm just waiting for the right card to do so. So anyways, as you can see, we have memory corruption on bank C0, C0. So that's good. That's the fact that we only have, remember, we're missing one memory bank and we only have errors on one memory bank, which suggests that it's the missing bank. This is a good sign. This suggests to me that the card is actually fixable and the GPU is good, but of course we still have to put on the actual memory. We have to put on another memory bank, or the old one if it turns out to be good, and then we have to actually properly boot the card. Okay, so as you may be able to tell, I've gone ahead and placed another memory module here. This is a D9 TCB by Micron. This is by far the most common GDDR5 module on an NVIDIA card. So let's go ahead and turn the card on and see if it, well, works any better. So booting the computer at the moment. Postcode B2, and if we look at the monitor, there we go, we have an image. So we at least have our card in a bootable state, so it can at least, probably get into Windows. I don't think we can actually yet use it to play any video games, and that's because we're still missing quite a few capacitors as well as on the back. And we also have to consider the capacitors for the PCI Express lane. So remember before we had those damaged capacitors on the last couple lanes? Let's go ahead and actually test them now. So I think if I move this over to my PCIe X16 slot, or at least the one that's electrically X16, it won't boot. But let's find out. I'm actually curious. I don't actually know what will happen. So again, it's booting at the moment. We just saw it work a minute ago. So okay, we're just waiting. I'm just waiting. My motherboard's taking its sweet time. And okay, I'm at postcode B2, and it does actually seem to work. So maybe I'm wrong. Maybe those capacitors are not as essential as I thought they were. But in either case, we're going to reattach them anyways, because why the hell not, right? Anyways, so okay, the thing we still need to, firstly, we need to reattach these two capacitors here, as well as a myriad of ones on the back. I'll probably, after I reattach them, I'll just briefly show that they're reattached. And then we need to focus on the HDMI port. Now, as you remember, the circuitry for the HDMI port was damaged. We can confirm that the HDMI port doesn't work. In the previous clip, when I said that back when we had a missing memory module, I said that the computer monitor would boot, not boot, but rather the backlight would turn on, but the screen would stay blank. I'm not sure if you could see on camera, but the backlight did not turn on, and the monitor was still definitely blank, and that's because, as I forgot at the time, the HDMI port had damaged circuitry, and now we know for sure it doesn't work. So I'll go ahead and attach the capacitors, and then we're going to have to focus on the HDMI port. So I've managed to replace most of the capacitors and resistors that are missing. I've just taken them off other dead cards that I have lying around. And at the moment, everything seems okay, except for the HDMI port. So remember before we had no image? Now we do have an image, but it's not exactly the kind of image you want. So as you can see, the thing is just covered in static. Now, this is because I've only managed to put some of the capacitors. No, I put all the resistors back, but only some of the capacitors. We'll switch over to a magnifying glass so you can see exactly why it's not so easy to put the rest back. Okay, so we're looking at the circuitry for the HDMI port. This is on the back of the card. Now, as you can kind of see, we have a few ripped solder pads. Now, in particular, we're looking at this one, these two, and then this as well. Now, I've traced out the connections, and as far as I can tell, the solder pads over on the right side would connect to these spots here for each data line, if you will. And these solder pads here that are all missing, all four in a row, they would connect to these pads here. So my plan is that I'm going to attach a capacitor to each of these, and hopefully wire the other end to these points. And like I said, hopefully we'll have an image, but we'll have to, of course, see. Okay, so at the moment you're looking at the repaired, I should say, circuitry of the HDMI ports on the back of the card. So as you can see, for those four capacitors that were missing pads, I've gone ahead and I've soldered them to the pad over here, but up, and then I've soldered them to their corresponding. I put solder on these. Wait, is that a capacitor? Yes, it is a capacitor. Hold on, let me get rid of that for a second. So, anyways, as I was saying, so I've put solder on these kind of pads. These pads over here, but on the top four, and then I've attached a wire from there to the capacitors that we've soldered to this pad. You can see the pads that they're attached to. So I've done a bit of checking, and I just want to point out, okay, so these two resistors are, according to my multimeter, about 0 ohms. This first row of resistors up here are all 5 ohms each, while the second row is 500 ohms each, more or less. according to my multimeter, which I don't really trust that much, these capacitors are all about 690 nanofarads. Speaking of capacitors, I've also gone ahead and replaced most of our missing capacitors, like these near the PCI Express slots. So these, they should be about 220 nanofarads. This one you can just read. These I can't get an accurate reading for. I think they're just maybe too big. And as for the ones on the back of the card, I've just replaced what I can using parts from dead cards, as well as the I've also replaced like the ones on the back of these memory pads. I can't replace all of them though, like this one, because it's missing a pad. But we're gonna go ahead and put the card on our test bench and see if we at least get a picture out of our HDMI. Okay, so we have the card hooked up to our test bench, and just to confirm, this is the HDMI cable. It goes into our HDMI port over here. It's the only HDMI port on the card. So when we boot the card, okay, you remember that last time when we tried to start the card with using HDMI, we did get an image, but it was all noise and static. So this time around, when we look at the screen, we have an actual BIOS splash screen. And in a moment, the BIOS start menu, just the BIOS menu will come up. There we go. As you can see, the image looks exactly as it should. So it seems like we have a working HDMI port. Of course, we have to stress test it. You know, I'm pretty sure it's perfectly good. You know, wiring. It turns out that our wiring job, as ugly as it was, is enough to get the HDMI port working. All we have left to do at the moment is to put the cooler back on and stress test it and see if the card is at least stable at, you know, its regular boost frequencies and it can actually run games without too much worry. Okay, so I have the card running a game. Unfortunately, despite what you may think, the card does not yet work properly. So all the clocks and the memory frequency look good, but you'll notice that the power consumption relative to TDP is only at 80% or so, or at least around there. So the card is being bottlenecked by something and it's not running at full power. In this case, it's not the game. If we look at, let's say, the bus interface, you'll notice that despite supporting PCIe X16 Gen 3.0, it's only running at X16 1.1. So the way a lot of these cards work is that they run at X16 1.1 when the card is at low power or idle or whatever to save, electricity, and then they ramp up to X16 3.0 when they need the actual performance. However, in this case, the card doesn't seem to ramp up to X16 3.0. So, like I was saying, it seems like it could be the capacitors that we replaced. Maybe I didn't do it properly, or maybe one's still dead. It might be it might be that transistor that I lazily didn't rewire. Maybe that's essential. But in either case, it seems like we have to go back and mull over the card a little more and figure out why this card isn't, performing at full speed. So we're looking at the capacitors that I replaced earlier, connected to the PCI Express pins. So you may remember that we had we couldn't get out of PCI Express X16 1.1, and we couldn't move to 3.0. So we had a performance bottleneck on our card when running games. We're gonna check each capacitor one by one, in the off chance that the source of our problem is just a botch repair job. So, anyways, let me just get started. So, our first capacitor is 201 nanofarads. That's fine. 225, still fine. 2.8, that's fine. 220, that's fine. 233, perfectly normal. And hold on, let me just do that again. And it seems like we can't get a reading on this capacitor, so you know what? I'm gonna go ahead and say that that capacitor is either bad or badly installed. I'm gonna replace it, and we'll see if the card is somewhat more functional. Okay, so I've changed the capacitor in question. Let's just take a small reading to see that we've done it correctly and we've installed it correctly, I should say. So remember, before we couldn't get a reading. Now if we check that sixth capacitor from the very right, we have 243 nanofarads. So now we do have a reading. Okay, so let's plug the card in and let's see if we have PCIe 3.0. Okay, so as you can see, the card is running. It's actually running a game at the moment. Okay, so here's the game. I'm not sure if I mentioned in the previous clip, but there used to be stutters when we were running it at PCIe Gen 1.1. Now though, as you can see, it's stutter free. So actually, let me just switch over to GPU-Z. Okay, so you remember before we were only running like what, 80% of TDP. So in this case, as it turns out, that's not actually a problem. That's just the game. That's the piece of software itself. However, the important thing to note is that if we go over to the graphics card and we look at the PCIe lanes, we see that it's now running at PCI Express X16 Gen 3.0. So it turns out that one capacitor that seemed kind of bad, either was dead or badly installed. Yep, changing that to a working capacitor, definitely working capacitor, and installing it correctly was enough to restore PCIe X16 Gen 3.0. So the card's been running this game for about an hour now, and I'm gonna go ahead and say that the card is fixed. I mean everything looks perfect. So, in which case I have to unfortunately ask that you consider a like and subscribe. A lot of these cards that I buy and fix, I should say, I have to buy them one by one, and as you can imagine, they can be pretty pricey. Cards like this, they cost quite a bit of money and they take quite a bit of time. My goal for this channel is to get to a point where I have enough subscribers and viewers that I can monetize the channel and start using the ad revenue to actually, offset the risk and make more interesting and better videos. So if you want to support that kind of content, a like and subscribe will go a long way. Otherwise, thank you for watching this video. I hope you enjoyed it, because I can tell you I definitely did not enjoy fixing this card. Hopefully, I'll see you in the next video.